Hope you all are doing well. Welcome back to my channel. Let's start with our next session of data structures and algorithms using C. Before starting with today's session, if you have not subscribed to my channel, please do subscribe it by clicking on the bell icon so that you can keep getting notifications timely. So let's start with today's episode. Before that, in the last episode, we took one very simple C program for swapping of two numbers. Right, guys? And I was expecting comments in the comment box. We did that swapping in 5 different ways, right? And I had asked you for the best solution. I'm still waiting for the comments. Let's continue with today's session. Now in today's session, we are going to discuss some basic terminologies which are needed to learn data structures. Okay. The first thing we are going to discuss, that is what is computer science. Okay. So you can say computer science is branch of science where we are mainly concerned with information organization. Your different information, you're going to collect it, record it, and you're going to organize it. So information organization, doing different manipulations on that organization, and utilizing that information in different application areas. Right? So in a very simple term, what we can say, computer science is concerned with information organization, means you are going to collect the information, record it, and maintain it in a proper organized way, doing different manipulations on this organization, and then utilizing that information in different applications. Right? Now, those students who are computer science student, right? The students of computer science, they will be mainly concerned with study of this information organization and how to do manipulation on that information. So in short, computer science students are concerned, or they are going to invest their time in information study, that is study of information and how this information is to be organized and how to perform different manipulations on that information. Getting? So information organization and manipulation, and that is only called as data structures. So you can say data structure is information organization and performing different efficient operations on it, like different manipulations which are in an efficient way. So in simple terms, what you can call a data structure as, so data structure is information organization and performing manipulation on that organization. Getting? Now there are many areas of data structure, getting, or there are many application areas where data structures are used. Right, guys? Few to list out. I'll list out few data structure areas. One, in the field of compiler construction. Getting? Many of you people now, those who are learning this data structures, they will study in their higher education compiler construction, like those who are from engineering and all, they have a special paper for compiler construction. Even BCA students, even MCA students and all, they have a separate paper called compiler construction. You'll realize that in compiler construction, use of data structures is there. In design of different database management systems, data structures will be used. in design of new operating system, like if you want to create an operating system at many places, like for your file management, even like kernel buffers and all, data structures will be used. Even for maintaining your process control block, getting as many number of processes are running, so they maintain its process control block in a linked list, and that is also what one type of data structure means. Here also your information is getting organized, and then you are doing different manipulations on that information. In the field of artificial intelligence, for storing different knowledge base, we will make use of data structure. Even in the field of computer graphics, getting in the field of computer graphics, like storing the information of your coordinates, then whatever pictures you're going to draw, then sometimes the picture is made up of complex segments. So to store that segments, you make use of data structure. So few areas I have listed out where data structure is used. Getting? So in crux, to just take a short recap of this whole discussion, we discussed first, that is, what is computer science. Computer science is mainly concerned with information organization, performing different manipulations on that information, and then utilizing that information in different fields. What computer science students do, they study this information organization, and they study how this organization of information is to be manipulated in different way. And that organization of information and performing different manipulations makes your data structure. Then we saw different areas of data structure where data structures are used. In the field of compiler construction, in the field of in database management system, constructing new DBMS, constructing your new OS, in the field of artificial intelligence, in the field of computer graphics, and many more. Getting? Now we will move on to some other terminologies. Okay? Now, in short, in a simple, short, sweet words, I will try to give you the definition of data structure. You can say data structure is a way of organizing the data, okay, in your computer's memory, and then performing different operations on it. Getting? But those operations should be in an efficient manner. Getting? So in simple terms, I can say data structure is a particular way of organizing data in your computer's memory. And after organizing that data in your computer memory, then you are going to perform some operations on it in an efficient way. Getting? Few data structures to list out. First is an example of array. Okay, I can take an example of array. Now, array is basically collection of homogeneous elements. Homogeneous means all the elements whose data type is same. Means they all belong to similar category. Values can be different, but the category is same. Like all are integers, all are character, all are strings, all are float. Getting? So array is again one type of data structure. Can you see here the information is organized in the computer memory in a sequential manner. All are kept from each other at a fixed distance apart. No one is scattered in the memory. Everyone is at a fixed distance apart from each other. Like if this is an integer array and it is taking 4 bytes, so everyone will be at a 4 byte distance apart from each other. Getting? So array is also one type of data structure where the information is organized in your computer memory in which manner? Sequential manner, contiguous manner. Getting? Every element is of the same data type and everyone are kept at a fixed distance apart from each other. So this is a one-dimensional array. Getting? Where you'll access the elements by giving only one single index. Right? two-dimensional where the information is organized in rows and column form. Rows and column form. So to access any element, you have to give the row number and the column number, and then you can access the value. Getting? So in short, in a tabular form. So we'll call it as a two-dimensional. Many such tables will be called as a multi-dimensional. So here you are going to access it by three numbers. First you will tell the table number, in that table the row number, and then the column number. Getting? This way it can be extended to any dimension. Okay. So array is also one form of data structure, right? So here we are going to organize this information in computer memory in such sequential way, and then we perform different operations on it, right? Then we have another data structure, that is linked list. Okay, here all your elements are not in a fixed distance apart from each other. Getting? They all are scattered in the memory anywhere, but they are connected to each other. They are binded to each other by keeping address. So first node contains the address of next. Next is containing the address of next. So this way all these elements are binded by these links. Everyone is containing the address of the next. And that's the reason we call it as linked list. Getting? Then we have another data structure, that is stack. It is a list of elements. Getting? List of elements, but that list is closed from one side and it is open only from the other end. Okay, and the side from where it is open, from there only you can add the value or remove the value. Therefore, in short, we can say stack is managed in a LIFO manner, last in, first out. Okay, so this is also another way of organizing memory. Getting? Means another way of organizing your data in computer's memory. One more is there, that is queue. In this you can see it is also a list of item like stack, but this list is open from both the end. From one end, which is tail or rear, you can add the value, and the other end, that is front or head, from there you can remove the value. Here it manages a FIFO structure. Why we call it as FIFO structure? Because the one who is gone first is the first one to come out. The one who gone as first element is the first one to come out. Now all these examples you might have seen, here the data is organized in all this in computer memory in different way, but they all have one similarity, that they all are linear. Linear in short, all are associated with one value. One element is associated with next, next is associated with next. Means they all are in line. Getting? Means they don't have a one-to-many relation. They have only one-to-one relation. Getting? Everyone is kept in a sequential manner. Right? But there are some data structures which are related with each other, not in a one-is-to-one relation. They are called as non-linear data structure. Getting? Where one element can be related with many. One-is-to-many association. Right? Example of that is a tree example, binary tree. Here you can see all your elements, getting, are not in the line. Means first element associated with next, next with its next. Not like that. Here one element is associated with many. So in the tree the structure is like that, that all elements are kept in such a way that one special element is called as a root and all other are splitted into again a tree called as a subtree. One subtree, another subtree, both are connected to its parent. Getting? So one-is-to-many association. Getting? One parent is associated with children. That child is associated with its child. Getting? And we call it as a binary. Why? Because every element is having at the most two children. By, that is 2. So every element is having 2 children. So here you can see elements are organized in which manner? in a parent-child relation. There is some parent, then children, that children is having their children and going on. Getting? Then another data structure is there which is in a nonlinear category only, called as a graph. There the association is not even in a parent-child relation, which is there in a binary tree. There one element can be associated with any. Getting? So here you can say like graph is a collection of nodes called as vertices, and then these nodes are connected by a line called as a edge. Okay, so graph applications many, like you can give your city map, okay, or country map is there, or your whole world map is there, or the map, or you can say your computer network is there, and then whole computer network, how one computer is connected with the other computer, that topology you can show it with a graph. Okay, and tree already I told you, but this tree and graph both don't come under linear category. Okay, they are coming in non-linear because one element is associated with many. Here one is associated with one only, 1:1 association. So these two examples are also type of what? Data structure, because here also you saw the way of organizing the data in computer's memory, and then you will be performing different operations on it, right? So in very simple term, in a very short and sweet words, data structure is way of organizing data in computer's memory and then performing different operations on it, right? Okay, now moving on to the next thing. Next thing what we are going to discuss is need of data structure. Okay, now guys, if you want to solve any data processing problem using computer, your problem is in which you want to take some data from the user, you have to process that data and then produce that result after processing that data. So if your problem is related to data processing problem, getting? So 4 important things you have to identify while doing this data processing problem. And obviously this problem later, ultimately, we are going to write program for it. And then that program, we have to tell to the computer that please execute it. So for identifying the solution to your data processing problem, 4 important things are to be identified. Now what is the first important thing? First, identify the data elements which you are going to process in your program. Now data elements which will be ultimately your variables and constants when you'll convert it into a program. Getting? So first thing what you are going to identify, the data elements. Getting? So to find the data elements that will be used in your solution of that data processing. Getting? So whatever your data processing problem is, so for that ultimately you're going to write a program for it, means ultimately you're going to write a solution for it. But in that solution, what data elements you're going to process, that first you identify. Just to give a very simple example, like if your data processing problem is calculating area of a circle. Getting? So calculating area of a circle, what first important thing you're going to process in it? The radius. Getting? Then you'll need one constant pi. That is also a data, no? Which you're going to process. And then whatever area you get it, that you will be storing it. So that area, that pi constant, that radius, these all are your data elements which you're going to process it in your data processing problem. Your data processing problem was very basic, calculating area of a circle, right? Now next thing what you have to do is, okay, the next thing is what operations you're going to do in that data processing. Getting? That operations can be very simple operations to any complex thing. Getting? But first you identify the operations. Getting? So different operations that you're going to do on those data elements, so that your problem solution you'll get. Whatever solution you want that solution. But to get that solution, what processing you're going to do on that data element. That is what operations. Like the example which I gave in area of circle. What processing you're going to do? Somewhere you will do multiplication, somewhere you'll calculate square. Like area of circle is pi r square. So r square means you'll calculate the square value, then that you will multiply it with pi. So multiplication, square, sometimes addition, division, all that also can come. Okay, so you first identify the operations. After that, you identify how these data elements will be represented in your computer's memory. Getting? So find the method of representing this data element in your computer memory. That whether your radius is going to be a whole number, then you'll represent it as an integer. If it is a floating point number, then you'll store it as double or float. Getting? But if it is double float, then internally it is stored as IEEE notation. Whole number it is, so it is simple stored as binary form. Getting? And if it is a negative value, it will be stored in 2's complement form. So how from your logical model it will be put into physical model? Getting? Means you have generally decided that these are my data elements, these are the operations. Getting? Now you have decided that one radius will be there, one pi and all. Now in your computer's memory, how they will be represented, that you have to decide. Getting? And finally you'll decide the language which will be needed to do this data processing. Because to do that data processing, you will have to tell the instructions to the computer. And how you will give the instructions to the computer? By using some programming language. So you have to select the language, okay, for doing this data processing. So decide the programming language for finding the solution to the requirement. Getting? Let's try to match this with the example I told, finding area of a circle. Now in this, obviously first thing we have done, we have found the data elements for this data processing problem. What are our data elements? Radius, area, and the constant pi. Second, the operations which you are going to do. So in calculating area of a circle, the basic operations are like finding square or multiplication. Okay, so operations performed. What operations you are going to do? Multiplication, finding square. Right, guys? Then how you are going to represent this data in computer's memory. So if your radius is a whole number, you'll store it as a binary. Negative numbers are stored in 2's complement, but normally radius won't be negative. In general, I have told, like in some other data processing problem where your data will be negative also, so negative values are stored in 2's complement. If you have this pi, which is going to be a floating point, even this radius can be floating point, then it will be stored in a IEEE notation. It's called as a Mentisa exponent notation. And then finally, you're going to decide the language in which you're going to do that data processing for getting the solution to your problem. Getting? So lastly, you will decide the language, right? And there are many programming languages. It is up to you, according to your problem statement, you can decide which language will be suitable for it. So you can use C, C++, Java, Python, and abundant of languages are there. Getting? And now in this whole thing, did you recognize that in this whole data processing problem, we have to organize the data and then we have to perform the operations on that data. Means ultimately there is a need of data structure. Getting? Then I hope till here you all guys are comfortable with all the terminologies which I'm trying to tell you. Getting? Now moving on to the next term, that is what is data and what is information. Okay, you can say the known facts. Getting? Whatever known facts are there, means which are having their meaning. They are not meaningless. They are having meaning. They have their intrinsic meaning. Getting? And the things which are true. Getting? That is, we can say the known facts are called as data. And that facts, you can record it in a proper organized manner in your computer's memory. In a proper organized manner, we can record and keep it. Getting? And then from that, you're going to get some refined data. Getting? Means after that, you will be performing some manipulations on it, and then we will be producing some other form of data. Getting? By applying some programs and algorithms on that data. Okay? How to do it? That is only the part of this subject. So what you can call it data as known facts. Means they are true. Those which are meaningful. The data is known fact, which you can record it in a proper organized manner in your computer's memory. And this information is having its original meaning, implicit meaning. Getting, guys? This data can be any form. It can be a text data, it can be numbers, it can be sound, it can be image, and many other forms. Getting? So these can be different forms of what? Data. Now normally programmer wants to do some processing on this data and get some other refined form of this data from this data. Means you have facts and figures, like you have different text data, number data, speech data, images data, but this is obviously meaningful. You have recorded and kept it in computer memory, but you want to produce some other meaningful thing from it, or you want to do processing on it and produce some new information. Getting? From it, I want to produce some new refined data from this, and that data you will be utilizing it in different applications, right? So for that, obviously we will write some programs, and that programs means in which we will be implementing different algorithms, and that programs we will be already storing it in computer's memory. So we can say this is computer. In computer's memory already what are stored means what are loaded, your programs, and programs are stored instructions. Now what is this computer going to do? It's going to run this stored instructions, but these instructions are performed on some raw data. Getting? So you are going to give some known facts, getting, to this stored computer, stored instructions which are kept in the computer. What these stored instructions will do, these will get executed one after another, and they are doing some data processing on this raw data. Getting? And they are producing some refined data, the transformed data. And this transformed data only is called as information. Means in simple terms, the raw data, when it is getting processed by the computer using these stored instructions or using these algorithm, and we get some transformed data, that is called as a information. Getting? So what we can say, computer processes raw data. Computer does the processing, but is computer instructed how to do that processing? Because computer is a donkey. It's a slave thing. We are telling to the computer what to do. Getting? And how the computer is going to do it? By following those instructions. That is your stored program. The computer processes raw data using your stored program. In this program, you have implemented your algorithms, your logic. So this stored instructions are executed, and while executing, they take this raw data and produce and give you some refined data. and that data is called as a useful data, or you can call it as information. Agreed, guys? Okay. Now, what all factors are to be considered while studying this data? Okay, so in simple terms, what is data and what is information? That is clear. So whatever facts we have collected and recorded and kept in computer's memory is data. And on that recorded facts, getting, when we are applying some algorithm, that is, we are applying some program, and then that program is doing some processing on that data and gives you some other meaningful output, the transformed output. So that we will call it as information. You're getting? Okay. So from this numbers, different numbers are collected. Like for example, you have collected the marks of student. Different marks of students are there. Getting? And I just want to find out the maximum marks, or I want to just arrange all these marks in a descending order. So what I'll do is I'll give this raw data, which is the marks of all the students. But in my computer, I have already stored the sorting algorithm. Means I have already written a program to arrange all these numbers in descending manner. So the algorithm for arranging the numbers in descending order is already fed to the computer. Now what this computer does, runs that instructions, right? And what these instructions do, arrange this and give you all that marks in a descending manner. So now that data only becomes a meaningful data because now it is kept in which manner? In a decreasing manner. You understanding? Clear? I hope it is clear. Now what I said is, whenever we are studying the data, some factors are to be considered. Now what are that factors? Okay, so there are 4 important factors. First factor is decide the machine that will hold this data. Getting? Meaning which processor will be there to process your data. So whether it is a Pentium machine or whether it is i3, i5, i7, many are there. Getting? So selection of machine is also important, because depending on the amount of data which you are going to process, the machine plays very big role. If you have a very huge amount of data, so your old machines won't be able to do it. So you have to do a proper selection of what? Machine. Getting? Which is going to hold that data for processing. Getting? Then second important factor you have to consider, that is which language of programming you're going to select for doing that data manipulation. Means, as I gave an example, that we are going to give raw input as marks of all the students, but I want all the marks arranged in decreasing order. Right, guys? And for arranging it in decreasing order, I'm going to write an algorithm for arranging it, and we are going to learn it in the next unit, different sorting techniques. Okay, now how I'm going to implement that sorting, whether I'm going to use Python for it, whether Java, whether C, whether Python, Pascal, so many different languages are there. Getting? So you have to do the proper selection of language. Okay, so languages required for describing your data manipulation. That is whether C, C++, Java, Python, so many. Third, how you are going to write the algorithms for it. See here, functions that describe what kind of refined data can be produced from the raw data. Raw input was marks. Refined data, all the marks arranged in descending. Getting? But for that, what you are going to write? Algorithm. That algorithm, obviously, you will write it using some languages. Getting? You'll implement it using some language. but you need to decide the procedure, no, for doing that transformation. To transform the raw data to refined data, you need to write some procedures. Getting? And that procedures are also important. So different procedures are there, and different procedures have different complexity from space complexity, time complexity point of view. Getting? So like if I want to do only arranging the numbers in descending, I have bubble sort, I have quick sort, I have merge sort, and everyone is having their pros and cons. Like, getting? So what we have to select, or what we have to write the proper procedure for doing that transformation. And for that we will write algorithms, sometimes pseudocodes, flowcharts, whatever. Getting? So remember, in this we are going to write the actual procedure, and this procedure will be transformed into a proper program using some language. So here we just decide the general procedure, how to do sorting. So we may draw a flowchart for it, or we'll write a simple English instructions. But later you have to convert it into a program by selecting the language. And finally, how the data is going to internally get represented in your computer's memory. Getting? So there are different representations, I told you. Like if it's a whole number, it is in binary form, whole number negative, 2's complement form. If it is floating point, then they are stored in IEEE notations. Different representations are there, like bits and bytes or words or IEEE notation or 2's complement. These are the different ways of representing your data in computer's memory. So whenever you're studying data processing, that is, you're studying how the raw data is going to get transformed into useful data, that time you have to focus on these 4 factors. Which machine you're going to use for data processing, which language you're going to use to write the data processing algorithms, then the actual algorithms, and finally how you're going to represent the data in your computer's memory. Getting, guys? Okay, for today's session, that's all. Okay, in the next session we will be learning some more terminologies, like what is data type, data objects, data structure. Getting? So stay tuned. Thank you all of you.